Welcome to the SQL over Streams panel. There's no real set agenda here. This is just sort of a chance for folks to ask questions of us regarding streaming SQL. I'm probably going to start out with an initial question just to kind of get the ball rolling, but I hope you all have questions to ask. And before that, I'm going to kind of do my attempt at introducing everybody here. If I get things wrong, feel free to correct me, but this will at least get us through the introductions relatively quick. So starting on that side, we've got Jay Krebs, CEO at Confluent, Apache Kafka PMC. Recently, no?
Yeah.
OK. Kafka recently came out with K-SQL, so this is sort of an interesting development in that space. Next up, we've got Julian Hyde. So he's a PMC member of Apache Calcite, which is Apache's SQL parser and optimizer system. Was also a co-founder of SQL Streams and is now an architect at Hortonworks. Then we've got Michael Armbrust. He is a software engineer at Databricks, the original author of Spark SQL, and also an Apache Spark PMC member. Stefan Ewan, he's the CTO at Data Artisans, Apache Flink PMC member. Flink itself has had streaming SQL in it for, what, a year and a half or something, based off of Calcite.
To varying degrees of sophistication.
Yes, to varying degrees of sophistication. And then I'm Tyler Akido. I'm a software engineer at Google, Apache Beam PMC member, and Beam similarly has a SQL DSL that came out in our last release, so the 2.20 release. So yeah, so I wanted to kick things off with an initial question, and then we'll kind of see where that evolves and see what questions we have from the audience. But just as an initial sort of starting point, the idea of stream processing over SQL has been around for decades, right? It's never really caught on well in my argument, or in my opinion. So my question is, what do you folks? Why do you think that is? Like, what do we think's been missing? What are the challenges ahead? What's resulted in this? And we've only got 4 mics for 5 people. So be friendly, and if somebody wants to talk, hand them around, and I'll stand here with my mic on. So, go.
I can give an answer.
Maybe. Can we get all the mics?
Hello?
Are all the mics turned up?
All right. Yeah, I think it's a super interesting question because this is a good example of something that happened in academia but didn't really happen, and now seems to be happening for real. I mean, it's too early to say, but so it's like actually academia working the way it's supposed to work, where it foresees future developments, researches into them, and publishes papers that we'll go back and read. So I have a couple theories on why this is. One theory is that you need the people who worked early on the SQL streaming were coming very much from a query optimization point of view, and it's kind of very natural once you think about these like volcano query optimizer data flow things in a database. You're like, oh, we could stream data through that. And the problem I think it ran into as a product was just people didn't really have ready access to data streams, or not in a way where query processing was the most immediate problem. I think that was maybe partially, I mean, Julian was involved, I think, prior to Calcite, like in a SQL streaming startup, and so he probably knows a much better answer to this. But I think part of this is like there is just actually a lot more streams of data. Like a lot of the IoT use cases that didn't exist. I think we take operational data streams about the operation of machines much more seriously, computers. I think the instrumentation of applications is now producing data streams. I think it's possible to start to think of a lot of these databases as generating data streams. And so, I think having that and then having it in a way where it's readily accessible. So like I was previously at LinkedIn, we actually started working on Kafka because we wanted to do stream processing, but we were like, well, currently there's no accessible streams of data. The first thing we need is some kind of like platform for the streams, and then we'll do processing on top of that. And so we kind of fell down this next layer. And so I think, to me, those are the 2 layers. Like, you kind of need the stream storage before you need the stream query processing, and then to just the prevalence of streams of data and the relevance of that to businesses. As businesses kind of get more digital, you're trying to react faster and use the data more naturally. If you're trying to make reports for people, then obviously the people aren't only going to look at the reports so often, like they don't need to be more real time. It's really when you're trying to make more continuous decisions. So at least to me, those are kind of the big ones. It was one of those things that I feel like 10 years ago got almost close enough and then just didn't quite get over the hump. We'll see if it happens this time. My sense is, just from the momentum in the area, it probably will.
So just to kind of echo some of the things you said, I think there's a couple of different factors that I've seen, at least from people who are using Spark Streaming. So one is availability of data. I think it's exactly what you said, like the ecosystem, the fact that Kafka exists and then all of the systems that look a lot like Kafka, Kinesis and PubSub and all of those things. Now that that data is available in a streaming fashion, now I want to answer questions about it. So I think that's maybe one of the things. I think another is scale. There's a wide variety of questions that people want to ask, where if you were running these as standard reporting queries and scanning all of the data from the beginning every time you wanted to update it, that you just wouldn't be able to do that anymore. And so if I compute these answers incrementally as new data arrives, I can always have my report up to date. And I think that kind of just that scale of data didn't exist before.
Yeah, just for the sake of just disagreeing a little bit, because I think there's actually Stream SQL has been around also 10 years ago. It's just not called Stream SQL. And what was called Stream SQL is not what we think it is today. So back then, a lot of the academic work on Stream SQL had a lot of these time series kind of aspects to it. And those were, I don't know, those didn't maybe catch on all that much. But they're like exactly what you were saying, having this like incremental evaluation of certain queries over data is in some sense what the databases internally did as materialized views and materialized view maintenance, which incidentally is like, at least for us, was the inspiration for streaming SQL, right? So there was something like streaming SQL actually. It was just not called streaming SQL, and it was something that wasn't, it was something that was not open, right? It was something that was like a particularly piece built into a sophisticated data warehouse or so. And in some sense, what's now happening is, kind of pulling this out as so many things have been pulled out, right? Like as the transaction log has been pulled out, as the data processing has been pulled out. Now this is the next piece of data processing that is being pulled out, the incremental streaming SQL evaluation.
So I see two factors. One is, so I was here, the first time around. SQL Stream was founded in 2003, and yeah, we were trying to convince middleware departments to use this stuff. And they were Java folks. I mean, they saw, they had IBM MQ series and JMS and all this kind of stuff, and they saw the stuff flowing over streams as kind of serialized Java objects, or perhaps RPC parameters or RPC results. They didn't think of it as data. And I credit Jay and Martin Kleppmann for doing the evangelism to tell the world over and over and over and over again, this stuff is data. It's not Java objects, it's data. It's the same stuff as is in your database. So that's one thing. The other is the value of the data. So probably 20 years ago, it's really worthwhile to think of what is the value of this record that is 1 minute old, and what is the value of this record which is 1 month old in terms of cents or fractions of a cent. And 20 years ago, or even 10 years ago, enterprises were not so real time. They were having difficulty just consuming the data from the previous quarter because BI technology wasn't that advanced. And now, now the enterprise is in the position to consume this data and act upon this data that is 1 minute old or 1 millisecond old. The only people doing the real-time stuff 20 years ago were Wall Street, and they were building their own technology. There was no interest in producing general purpose technology. So those are the two things that have shifted, I think. And we're in the middle of, or at the start of this kind of exciting journey to bring streaming data to the database community.
And I'll try to add two more things. I may be repeating what you said because I was not paying attention as I was plugging in my laptop so the slides would come back. But what I think is another facet of sort of streaming SQL has been around and been used is materialized views. I think is actually a good sort of example of like those things get used constantly, and really that's a form of SQL stream processing, right? It's the simplest to use, most understood version of stream processing out there, really. And there's broad use of it. So from that perspective, it actually already is there. It's just when folks want to actually operate on the output as streams and not as tables, that's kind of where things have fallen down. And so I think the other aspect is I don't think, like all of the previous systems that have tried to tackle this before this current generation, I feel like they just didn't quite get there. Like they were like 99% of the way there, but it was just that last little bit just made it just didn't quite fit together well enough, or wasn't quite useful enough that's kind of another part of why it fell apart. Or at least that was the sense that I got. I wasn't actually involved in it, but sort of retrospectively.
I think another thing that may have changed is open source. I think it is actually hard to make really practical systems purely in academia. I mean, people try, but the contact with the actual problems and what would make it usable is less. And then the difficulty of getting like really novel infrastructure startup off the ground with pure proprietary code is just difficult, right? Because people are like, well, you're a very small company, I don't really want to bet on this, it might not be around. And I think open source really allows these things to get out there faster and kind of spread. You can kind of find the early adopters on its own. And I think that's actually a pretty powerful mechanism for getting new ideas out in the world. And I think it would certainly be much harder for this current generation of things if we were building them purely as proprietary systems and just trying to go door to door and sell it.
Yeah.
You know, done that.
All right, so audience question. Here, maybe I'll run mics.
Thanks a lot. So I'm sort of getting the sense that we're now getting there, but to me, and I hope this will trigger you, it seems a bit too good to be true. The materialized views I get. But what's now the essential difference between the new state and materialized views? Because I hear Michael say, well, but yeah, sure, you instead of continuously building up your view from all of those events, which is impractical, you can just snapshot your answer and always have this answer in place. But that means you effectively need to build up already your query, continuously know what you're doing and what's the difference with that and a materialized view. And also, it appears to be rather monolithic in the sense that there is a single truth and I can query it and I get the truth. But with our amounts of data that we're talking about in these use cases that you're describing, I can't kind of fathom that.
So, I mean, I think the thing that's different, I mean, it is a materialized view, but it's kind of exactly what Stefan was just saying. We've exploded the database and we've taken key pieces out. So I can take that incremental view maintainer and I can feed in, terabytes of Parquet data from S3 and have the entire feed of everything that's ever happened. And I can read super low latency data from Kafka, and then I can output that to Cassandra, which is going to store this gigantic answer and make it queryable. And I think the fact that we've exploded the database and added nice connectivity on all the different sides is what's kind of different than what you got when you took like a single black box stream processing engine. There were a bunch that were built on top of Postgres that were like single node in just one instance. So I think that's what's different.
Yeah, I would totally echo that. I think there's a couple of aspects that are really important. So I think, there's lots of things you could view as just a materialized view. And so when I was starting on this, I had conversations with a bunch of people in academia, and they're like, yeah, we looked at that area, but it's really just, but like, if you think about like Google search is just a materialized view on top of the, the web, right? It's just that. But if you think about the mechanics of implementing Google search using like triggers and like whatever, like that's not really going to work, right? Like you need a platform which is targeted at doing something, which has scalability, which can have multiple teams all working together and collaborating and deploying code and so on, to really be able to build serious chunks of your business that way. And so when you look at parts of a business, yeah, a lot of what they do is materialize some view on data, but you have to have like a real platform for that. And so I think, at least kind of our view of the world is we really want to make it possible to have these streams of data kind of span the company and make that open as a programming paradigm, right? So you should be able to write code in whatever programming language you like that uses that in kind of a lower level way. You should be able to have higher level stream processing interfaces that make some of this stuff easier. To me, I think the SQL layers are yet another interface that like makes a ton of sense for this kind of thing. I think you see a ton of traction for these serverless function as a service type things, which I think it actually has some advantages as another interface for this. But I think the fundamental thing is really the ability to build around these streams of events. Like, this is what's happening in my business, this is what I can compute off of it. And I think we're kind of just early in making that practical. You know, whenever you come to these conferences, it's like it's already done, but in reality, it's like 10% done. And I think as it does, it's going to be really cool. I think that's actually going to be substantially different, even though conceptually it's very similar to stuff you have in database theory or database papers or databases. I think the actual practical application of deployment of that in the world is going to be a big deal.
And I think there was also one part to the question. So, you know, you now have this thing that computes the materialized view, you know, be that across X different systems that are integrated in this nice, you know, open interfaces way. But yeah, there's obviously always still a decision to make. What do you want to make as a continuous piece of computation versus what do you want to make an ad hoc piece of computation, right? For the continuous computation, the streaming computation, you pay a bigger resource footprint, typically because it keeps running all the time, but it also gives you ready results, right?
Although you don't have to. Although you don't have to.
You can also like time discretize this or so, right? But then again, you don't see the results immediately there at the same time. So there's kind of always this trade-off, like do you keep it running for being immediately up to date, or do you pay the cost of computation at the point when you ask, right? And yeah, I'm not sure. Like the databases actually then came up with all of these fancy tools like design advisors. What should actually be a materialized view to compute based on? This is something I'm interested in. So that should be a materialized view. I don't know. I mean, maybe at some point in time somebody's going to write something like that for for this ecosystem. Here's the different pieces that I'm interested in. Here's my resource budget, and it spits out. Okay, these and these things you should actually compute in streaming fashion eagerly. Those things compute them lazily on query time. Might be, but I think that's going to be a bit away. We still have a few problems to solve before that.
Yeah. So, if the question is, should I do streaming? It comes down to that. It's how valuable is this data when it's 1 minute old versus one second old? If it's, if it's still as valuable in 2 hours as it is now, don't do streaming. It's definitely easier to work on data at rest.
Disagree, but if you're going to run this query more than once, you should consider using a streaming system. That would be my argument. And I think really what it comes down to is it's really all about incremental computation. I have seen so many people write batch jobs that run once a day, and they spend so much time thinking about the logic of figuring out what's new, what's old, what was my state from before, what happens if it crashes in the middle, and that is exactly what streaming systems can solve. So even if you bring up your streaming job once a day to run one giant batch, you should still be using a streaming system.
Or at least a streaming programming interface. I think this is where you have to start to differentiate, right? Modeling something as streaming, like almost always makes sense unless it's an ad hoc thing. If it's longer lived or run more than once.
There's like one API for describing data flow, and then there's like an execution engine under the covers that makes it happen.
It is more complicated. It is more complicated to write a continuously operating ETL process than a SQL script with insert into, select from. So there is a cost to this.
Well,
we're trying to reduce the cost of this, but
I think there's a hidden cost of not having a streaming system that's
agreed.
And so
I'm playing devil's advocate here.
No, and I appreciate that. But like I think the onus is on all of us to move streaming systems to the point where it's as easy and natural to do that and have use the right tool. Like our tools aren't good enough yet, is I think the point.
But the flip side of the question is, if you are doing streaming, why use SQL? Which was not self-evident for many years. People accepted the idea they would use SQL for database stuff, but they didn't see the point of using a declarative language for streaming. So there's, we're just about getting to the realization that there's a point to use a declarative language for streaming.
And to throw one more thing in there, back to the original question of how is this different than materialized views? If you think about materialized views as essentially taking a table or a stream and materializing them as a table. The other part of that that's interesting is what if you actually want to consume that as a stream, right? Like materialized views are kind of like table-to-table transformations. But there are use cases like anomaly detection that don't really fit nicely to a materialized view. Like you don't want to have a table that kind of tells you, is there an anomaly or not? And I'm going to go and scan through all my keys and find where the anomaly is, right? Like there are cases where you want to consume your output as a stream and not just a change log, but like you've got the interesting events only in that stream. That's where the non-materialized view sort of approach actually becomes really interesting in streaming SQL or stream processing in general. Yeah. Thanks.
So if you have a SQL database, you have this piece of computational infrastructure running, and it's packed full of data, and a whole bunch of people can just ask it SQL questions whenever they want, right? In a lot of the SQL streaming stuff I've seen, it's really just a DSL for building a data flow. And you sort of throw it up there, you start all the containers and machines or whatever, pump all the data through it, and then it starts spitting out answers. It almost seems like there's some kind of waste there where if you were going to make a closer analogy to the database, you would have this SQL execution, like streaming SQL execution thing. And anyone, let's say in the company, can throw SQL questions at it, but rather than getting back a response right away, they get back a stream of response. But then the execution engine has an opportunity to take all the different SQL questions that people are asking it and do some algebra on them and optimize, right, and build intermediate streams and then take advantage of, like overlapping parts of it. Is there something I'm missing, or is that pretty much the shape of it?
Is that a question for Julian? When is CalSite going to do common
It
sub-expressions?
So
When is CalSite getting common sub-expressions? I think that would be.
Yeah. When my friend Jesus gets around to it, he did a PhD on common sub-expressions, and Hortonworks are keeping him so busy, he's not got around to putting that into CalSite. I like the idea of SQL as a language, but I would love to see a hybrid system that has where you use SQL for access to streaming data and historic data, and it's perhaps it's backed by a combination of HDFS and Kafka and data in memory and a variety of storage systems and perhaps a variety of engines, but it's one interface. I think one of the most compelling reasons to use SQL for this stuff is that you can look at a stream and the last 10 milliseconds of a stream, but also the last 10 years of the stream in the same query. Combining historic data and streaming data in the same query is a very powerful paradigm. And so it's the optimizer job for life. It's the optimizer's job to figure out where's the best place to get this data from that they're asking. And yes, recognize common sub-expressions and perhaps create materialized views on the fly. Or a materialized view might just be an in-memory hash table. Or it might be just realizing this data is I can do a time-based scan of Kafka to find this stuff. So there's this is what got me started as an optimizer guy. It's an opportunity for the optimizer to be smart and know about data sources that you don't know about as an application developer because you're only trying to write your application.
Yeah, I would strongly second that. I think the combination of point-in-time lookups against the data that's been materialized, as well as the different, the ability to control that continuous materialization, I think that is the key value proposition. And I think it is not quite there yet because the stuff isn't done yet. I mean, that's my take anyway. And I think that's exactly what people want.
Anybody wants to ask a question, come get a mic.
Yeah, I like that plan. Just keep one of them out.
Yeah, you can keep that
Hello.
mic out there and
Yes.
just hand it around. Yeah. Go
First, I'm really excited about this streaming technology, and at the same time, it touches about SQL because, by the way, I work for a company who deploy wind farms on the sea. So we have like 1,200 turbines running, emitting a lot of basically sensor data tags, basically. And this is the biggest challenge that we have, because at the end of the day, the business would ask, I need to know the alarms emitting in this wind farm now. We can't do that because it's available on a SQL table that's basically being backfilled by a batch process. So if this presents these opportunities, I'm thinking, should we fix it here or we go to the source? Should we go to OPC Foundation and say, hey, OPC Foundation, which is the organization building all the industrial communications, could you open up and make it streamable? That's just a thought. Instead of building, because what I'm thinking here is, now we are building a streaming middleware with a source that is not stream ready. So, something like that. So, it's maybe not a question, but a thought that eventually maybe it's like a false streaming because your source is actually not stream ready.
Yeah, I think it's a great point. We thought a lot about this when we were starting on Kafka a long time ago, which is, yeah, if everything was already streaming ready, then that would be great, but you kind of are in this intermediate state. I think there's a couple things you have to do to kind of move the world, right? It's like a little bit, if you have to do a little bit on the supply side and a little bit on the demand side, and then they kind of bootstrap off of each other. So I think like getting really good streaming connectors for different systems, I think is incredibly important. That kind of makes data more available. All of these processing technologies, I think they make it easier to use streams of data, so it incentivizes you to capture and extract them. I think those two things have some interplay. Like we've seen in companies as they adopt this stuff, yeah, initially it's usually for some one application that maybe they're generating custom event streams out of their applications. But over time, they'll often start to collect a lot of data that's in existing databases, a lot of things across the business, but you have to kind of start that bootstrapping within the company before you get some kind of center of streaming data. As there's more stuff there, there's more incentive to add new things, because there's really a lot of value you can build against there. But getting those first few applications off the ground is really important. And then for the larger ecosystem, I think we're in that bootstrapping now. At least from my point of view, I think it's very likely that we've gotten critical mass with that. So I think it'll continue to build. And that kind of makes it where a lot of people who are thinking about devices or whatever, standardizing how that can connect, I think a lot of that will start to come together over time. But you kind of have this chicken and egg problem where you have to have the central platform for streaming in order to get the streams, but you have to have the streams in order to want the streaming platform. And so I think we're literally watching that happen, where there's all these cool different ways of processing streams of data and ways of storing them. And I think it's kind of coming about as we speak, hopefully. So maybe what you described will happen.
Yeah, because normally you have a FTP system, which is basically being fed by an external party. Then you have a real-time system coming from sensors and OPC signals.
Yeah, one thing we have tried to do to make that possible is, to the extent you can make the streaming layer like Kafka really work as a storage backbone, so you can store data, you can kind of upload files or whatever and treat that almost like a stream of events that just happens in a very bursty fashion and still process it in the same way.
Yeah, this goes kind of in the direction what I also wanted to say. Even if your data is provided in like bursts of an hour or so, you could still start modeling this as a nice streaming problem. You just have a piece in your streaming pipeline that happens to have a quite high latency, right? In a similar way, if your data source is actually a file system in which like rolling files appear once per hour, you can start actually treating this as a streaming system. It just happens to have a latency of an hour in its current state, and then if you happen to be able to swap that piece with something that's more immediately publishing data like Kafka or so, then you immediately get the benefits, right? So you can actually start working on the abstraction before each individual link is there, and you already get quite a bunch of nice benefits out of that. For example, if you FTP files one by one and you run the queries one by one, you always have the problem of like broken boundaries of, there's some events in here that might have come a little late, should have been in the previous burst. You kind of manually have to correct this and so on. So actually modeling this as a stream kind of gives you the nice behavior already, and then you just have, just keep working on the latency of each link in the chain.
Can I add to that? I want to give a plug for Apache NiFi, who've thought about this problem. The model there is, I mean, the marketing folks told me is streaming. Apache NiFi isn't really streaming, but the deal is it deals very nicely with the problem of Internet of Things, where the data tends to remain on the device, and the device might be sending one message per minute, but if something is wrong, then the entire data set is still there on the device, and you can kind of go back to it. So it's kind of lumpy streaming. It's mostly push, but you can switch to a pull mode of operation to get extra data from the device if you want to. So it's very, very interesting mixed streaming relational problem. And I mean, Kafka is awesome if you're in the data center, and obviously every device is always connected to, every machine is always connected to every other machine. But in the Internet of Things world, where connections are less reliable, power is an issue, then it makes sense to move to a slightly different mode of operation.
Thanks. I have a different kind of question. My name is Suman, and I'm from Walmart Labs. So we use Kafka heavily. Jay knows about it, and I think the question I have is, with all this big data and querying that we are talking about, have you guys actually thought about using GPUs and GPU memory databases and all that good stuff?
We looked at that a little bit. I would say our take is this. There's definitely scalability challenges on the edge of streaming. But I think the most interesting space is actually the opposite side. So I think the world has been very focused on big data. There's definitely some valuable problems which are extremely large. A lot of valuable problems aren't that big, but there's a lot of them within a company. So if you look at the, what is the work done inside my company, there's this apex of problems that's extremely large. Often those large problems are not the most valuable ones. I mean, sometimes there's some value there. And so at least for us, we felt like actually what people miss in the streaming space is the ability to actually generalize like what databases do and really empower like all the apps, not just the big ones, and actually make that really usable and powerful for that kind of thing. And a lot of the use cases I'm most excited about for Kafka or KSQL or any of the stream processing layer there, they're actually not the biggest ones in terms of raw scale. There's definitely these like freakishly large ones where you're like, oh my God, like that's just a lot of computers. But they're the ones that are like really at the core of the business, where you're doing something and you're like, oh my God, I can't believe that they're doing that with like Kafka and stream processing, where somebody's building like a financial exchange, or they're like that kind of really core stuff. And I think maybe we as technologists in an industry, we've kind of fetishized big a little bit. And I think a lot of what I think that makes sense because big data was attacking a space that was very mature. And so like actually there was a very mature solution to many of the other problems. I think stream processing, I don't think it's really existed. I think there's older messaging systems. I think there's just not like a mature solution in this space. And so my hope is it will actually be something that is applicable to like 30% or 50% of what a company does, like all that asynchronous logic that happens that runs the business, not just these kind of like insanely large, like, oh yeah, we instrumented, every little twitch that the motor made on every vehicle in every car everywhere. I mean, those are amazing problems, of course. But there's also these incredibly valuable lower volume things that also need to be modeled and integrated and tied in. And that data is often the most important stuff. But I didn't really answer your GPU question. I mean, basically, yeah, I've seen a couple startups focused on it. The number of times I've gone to a customer and they had a problem that was so big that it would have made more sense to focus on something like much more customized. I think it is kind of on the edge of the signal processing, like more out there problems like particle physics and accelerators. You go to a bank and like there's a bunch of really important stuff happening that's making a lot of money, but it's not like they need like new types of CPUs to process it. Maybe the machine learning space is the counterexample to that, like training machine learning models, but I don't even know if that's particularly the earliest adopter for stream processing.
Yeah. just to add another point to that in some sense, yeah, I would also say if we look at the problems that people report, okay, we're trying to do this and we're running into an issue here, like scale and performance comes up in rare cases. It's mostly around, can I actually represent these semantics in an easier way? How do I operational questions around this, continuously running systems come up way more often than somebody says like, hey man, if you can reduce my number of nodes here by a factor of 5 by plugging in a GPU, I would say, yeah, I would agree with Jay. Most problems have way more tedious questions. So also in the stream SQL space, right? You can start with like optimizing the hell out of the system with thinking about things like GPUs and so on, or you can start first trying to think about being smarter in the incrementalization and so on. And it seems I don't know, that's my take. In where the space currently is, being smarter in the incrementalization, for example, there's still much more to be won than trying to plug in dedicated hardware.
So I think Jay just had the quote of the day. In IT sector, we fetishize big. I'll take that away. Anyways, I have a very different question, and I think two guys on stage definitely know what my question is all about. How about the metadata? Because you guys, you correctly saying it's all about the data, but I would really like to look at the data through a lens of metadata, and I think it's not existing yet in this space. What are your thoughts?
Yeah, I mean, I second the importance of that. I think we're kind of clawing our way up the stack here. Like the original Kafka work was how can I reliably get streams of byte arrays around, and then we add some processing on capabilities on top of that. And the problem you have using this at large organizational scale is all about like, okay, what the heck does this mean, and what's my contract to you, this other team that's continuously generating data as your software and project changes. Like we've done some work on that stuff at Confluent, trying to represent schemas and stuff, but it's still very much like the year 1 of 10 on how metadata should evolve. And I do think it's one of the most critical things. It does tend to be the problem that comes out with at-scale usage. So it's like not in the path of your first 3 use cases, but it's absolutely in the path of your first 30, and it's like really in the path of your first 300 or whatever. And so you can definitely see that if you kind of tour the Silicon Valley companies that have done these big central pipelines of streaming data and have a bunch of applications hanging off of it. I think they've all gone through what I would describe as schema hell in some sense, either the hell of not having a schema and then trying to like live in a world where all your data can change out from underneath you every time anybody releases code anywhere in the organization, or the hell of having to figure out how these things evolve in a principled way.
Yeah, so I mean, that's definitely a huge problem. And I think if you go back to like Stonebreaker's paper about how MapReduce is a huge step backwards, he'd be like, you guys still haven't figured it out. I think there's a lot of work going on here. I think it's not just about schema, but it's also about provenance and data discovery. What does this column mean? How did it get created? And so I think I'm seeing a lot of cool stuff happening there. But yeah, it's definitely not something we've solved yet.
But to some extent, that's actually not even a particular streaming problem. I mean, this is like data processing in this stack in general. I mean, my first assumption would be that the amount of added metadata and streaming isn't actually, if you model it in the correct way, all that much. If you go to a higher view, like the time varying relations and so on, you probably want to explicitly state a few things like how to express time, how to handle time, certain amounts of like retention periods, granularities, and so on. But I guess the complicated stuff that I think especially you might be also interested in like exactly all the provenance. What does this particular column affect? Right? If somebody tells me in the sense of the right to be forgotten that for that user that column now has to be dropped, what are all the downstream effects that I have to recompute to actually make that happen? That isn't even a particular streaming problem. I think that's just a general data processing problem that the entire space hasn't
I mean,
fully solved.
I think it's a problem of integration. It's like when a bunch of things come together, then suddenly it's like, how do these teams work independently? And I change my thing, and your thing, does it break? And what are the dependencies between? So to me, it's very much the same thing happening in the microservices world of like, what's my contract to you? And like, how am I allowed to evolve that contract over time? And so I guess the only reason it's connected to streaming is to the extent that people are plugging together around these streams.
Yeah, I should correct myself. Given that, like all the microservices and data pipelines, it's all some form of streaming, then of course it's a streaming thing, yeah.
So the metadata is kind of inevitable when SQL's in the picture. You can kind of tell when someone's building a SQL system because all of a sudden they need a metastore. So, Spark went through this evolutionary path, right? Initially, Spark, all the metadata was in the Scala code, right? It was known to the Scala compiler, and as soon as you guys started building Spark Sequel, you needed a metastore. Kafka's kind of, well, you needed to know the Avro schema, but no, you didn't need any richer schema than that. And so Kafka's kind of following the same path of getting, it needs, as soon as you're doing SQL, you need a metastore, and it turns into it's a big strength because now you've got an organizational view of because the data is externalized from the application, because the metadata is externalized from the application, now you've got an organizational view of who's using what, and you can have integrated access control. You can say, Jay is allowed to read this stream, and this table, and this view, and so forth, and it's easier to do data governance. So it's one of the kind of side benefits of SQL. What is unfortunate is that the various vendors are pursuing their own metastores right now, and I'd like to see us converge. Particularly these guys either side of me, and us too, right? I mean, Hortonworks is very interested in getting stuff in the Hive metastore. I don't want to see the metastore becoming this point of this opportunity for vendor lock-in, because as I said previously, I'd like someone that's using KSQL to be able to see Hive tables as part of their KSQL query. Let's not go down a path which involves us being balkanized. So if you're in KSQL, you can only see data which is in Kafka. That would be unfortunate. So let's work together, folks, and we're all building our own metastores, but let's make it so that my metastore can read from Jay's metastore and Michael's metastore.
So we've only got like 4 minutes left, so probably one more question. Manal? All right. Okay. Fight.
Maybe 2 more questions.
Yeah. We'll make it work.
So we have 4 representatives of 4 different stream processing engines here. Could you guys compare and contrast the SQL over streams report in each one of them? And don't hesitate to say why yours is better than the others, because we'd like to hear some powwow.
Well, I'll say Calcite is not a stream processing engine. It's a, I'm evangelizing the idea of streaming SQL, and there's a reference implementation inside Calcite, which is really no good for serious use. That's true. Although I'm no longer with that organization. So.
Yeah, I can answer. I mean, I think it's early for like a serious bake-off in the streaming SQL space, just in terms of completeness of the products. What we did at Confluent was something called KSQL, which is meant to just be a SQL interface for Kafka. It puts together the idea of tables, which are these kind of incrementally changing mutable things in streams, and tries to let you work across those two. I guess our vision for it is just to make it as complete an experience of working with these streams of data as we kind of make it well integrated with Kafka. But I think we're super excited and have people using like literally everything represented on stage here with Kafka, as well as like 15 other things, including weird stuff I almost never hear about. So that I do think this is like big tent
time in the stream processing world. You know, we're still trying to get the boulder to the top of the hill and kind of get it rolling. I also don't think that the processing layer is very prone to monopolies, personally. I think it's very nice to be able to get these streams around and interface on that, but I think there is actually a ton of value in a SQL interface. I think that there's a ton of value in programmatic interfaces in all the programming languages you want to use, and really making that a first-class citizen, not something you know, kind of half-baked. I think that there's clearly something to these function as a service, serverless stuff that people are doing. It's like, you know, really people have a lot of interest in that. I think that there may be other more out there interfaces we haven't thought of. I'm waiting for the data log, you know, SQL data log, or data log streaming implementation to you know, get some traction. So I'm not sure that I'm not sure it's really a zero-sum game, just because the total number of people building around stream processing is still, you know, I believe, a small fraction of what the total space is going to be. You know, I would hope in a decade, if any or all of us are successful at what we're trying to do.
Man, everyone's being so polite. Yeah, so I think it's super awesome that there's so much work going on in streaming. I think, like, and in fact, I spent lots of time studying all of the systems up here as we were building different things. I mean, the things that I like about Spark are, I really like the data frame and data set APIs, which is one single API for doing both streaming and batch, whether it's functional object-oriented stuff, or whether it's kind of relational link style queries, or whether it's SQL. And then I think the one thing that's my favorite about the way the execution engine works is all three of these APIs compile down to one logical plan representation, which goes through Catalyst and Tungsten, which we've spent the last 5 years optimizing the performance of. So those are the kinds of things that at least I've heard that users like about Spark.
Okay, I'm going to follow up a bit more in the Michael way. What do I like? What do I like about Fling? I think what I really like about Fling is the way it's been built from the beginning as like a proper streaming engine. It's developed an interface that's also a unified batch and streaming interface. Has like slightly different runtime operator implementations, whether you go like the batch way or the streaming way, which are, you know, getting closer together. And it's actually come up with a very interesting way of executing this streaming SQL, for example. I think, which is different from for example, K-SQL and Spark SQL, where it really takes this idea of the materialized view maintenance and actually internally does a ton of work to really incrementalize these things. So you can really get a very low latency stream of updates that basically tell you how do you have to modify your result. Do you have to add a record? Do you have to remove a record? Which is extremely powerful. You can actually get the most fine granular deltas to your results that you can possibly get with the lowest possible latency. And yeah, I think that's actually a pretty cool way. Whether this is exactly the use case you have or not, you can always go more coarse granular. You can always try to choose to not use it, but you can actually do this. You can actually make this a standing, very low latency differential query if you want, which I think is really cool.
And then I'll sort of give a quick answer for Beam. So Beam's somewhat different than the other folks that have talked, and that, you know, Beam is essentially a set of APIs and a portability layer. And then so what's interesting there is that, you know, we can provide a SQL implementation or non-SQL, you know, whatever APIs are provided, and then give you this consistent experience across different platforms. And another aspect that we don't have fully done yet, but this portability layer, once the full vision is in place, will essentially let you mix and match, you know, any language, you know, be it SQL or Java or Python or, you know, JavaScript or whatever, with any of the given runners. So, you know, and this kind of speaks to what Jay was saying earlier. You know, it's not, you really want to be able to have things available in the language you want to use. You don't always want to use Java. You don't always want to use SQL. And so having this full multiplex of, you know, you can build any Beam SDK and run it on literally any runner, even if it's, you know, a Haskell SDK that then runs on, you know, a Python runner or something random like that. Like, I think that will be really powerful. But from that perspective of that being sort of what Beam is within the ecosystem, I think our approach, or at least my approach, has been that we need to figure out how to make streaming, how does make SQL particularly fitting in with streaming, you know, understandable, easy to use, and clean as possible, because we really like how well it works, you know, how easy it is to use and easy to understand is really important from that perspective of where Beam is trying to sit within the ecosystem. And then there's, you know, once that sort of compiles down to, as Mike was saying, of this sort of common execution plan, then, you know, from there on, the runners can just kind of take it and run with it.
And let's remember that the majority of SQL in the world is not written by people; it's written by tools. And so this is one of the reasons that SQL has this amazing momentum. Is, you know, tools such as Tableau and Excel and so forth. If you make your system speak standard SQL, then all those existing tools will be able to talk to it. These tools, actually, most of them at this point want to talk relational SQL. They want tables. You know, something like Tableau displaying a dashboard. So let's not forget that, you know, even though the data may be arriving using a stream, the system actually wants to see relations. It wants to see materialized views. So that's a really important feature of any of these systems, is the ability to provide up-to-date materialized views.
All right, we're probably technically out of time. If your question's really fast.
Okay. My question is related to microservices and Kafka. Kind of related to streaming. If I emit the data from microservices and Kafka becoming essentially a distributed data log. So can I use streaming API, or is it a good use case to generate materialized views across data sources?
Yeah, I think there's a hidden like phase shift. I think a lot of the stream processing thought came out of the database world, especially the analytical database world, and the big data world, like especially Hadoop. Right, and a lot of those problems are these kind of analytics reporting problems. But once you change the latency, you actually move into the operational domain. A lot of the stuff that runs the business, like, is directly in the path of the customer experience. And so I think, you know, the way that group of people is different. I think that there's not really a difference between a microservice and any other chunk of code. But we've been talking about it that way because at least it actually makes people think about these use cases that are not just purely real-time analytics, which I think is actually a subset of the value that's capable here. So yeah, I mean, I guess our view for this is really making Kafka and these streams of data kind of a central hub that things can form around. And you can basically implement a microservice in a program that subscribes and transforms these streams. And you can kind of view a microservice as something that takes streams of events and outputs, you know, streams of output events, or makes changes in the world elsewhere. And you could implement that transformation. You could implement it in, you know, the processing layer in Kafka, the Streams API. You could implement it in, you know, any of these other systems up here that, and, you know, maybe some are more convenient or they're suited to your language. But that can be a way you can kind of build your core business around this, and you could actually view a business as something that works off these streams of events and reacts to them and does stuff. I think it's actually a powerful view.
Just to add one sentence in the Stream SQL context to that, Stream SQL is certainly not just something for analytics, right? I mean, an application like a microservice that is built on streams can have a part where it you know, compute some metrics in a SQL fashion, because that's just a very nice and efficient way to define it. And then these metrics are consumed by a piece of business logic just in the same process, maybe even, you know, compiled down to the same syntax tree and everything, right? I mean, it's just, SQL is but in no way in the Stream SQL space something that's purely limited to analytics.
Yeah, and I didn't mean to imply that. I just mean very often people jump from stream processing to real-time analytics, and I think that connection should be less strong in people's heads when you look at compelling use cases. Some of them have analyticalness, like they're aggregating stuff, but they're often not what people think of as analytics. They're not built in the same way analytics things are built. They're ultimately not consumed by humans looking at a report.
Sometimes it's just plumbing.
Yeah, yeah. I mean, sometimes it is actually the software that runs your business.
All right, so I think we're out of time and beyond. So thank you all for coming.